Since its successful debut in 2017, the C919 has symbolized China's ambitions to soar into the skies of aviation history. But behind its thousands of orders and technological breakthroughs lies a challenge that could shape the future of China's aircraft industry. This is the story of the C919, its rise, its struggles, and its potential to rewrite the rules of the global aviation market. In May 2017, the world watched as the C919 took off for its maiden flight. It wasn't just a test flight, it was a statement. With this aircraft, China joined an elite group of countries capable of developing medium-range passenger jets, putting it in the same league as the United States, Europe, and Russia. It was a bold move in a market long dominated by Boeing and Airbus. The C919, designed and built by the Commercial Aircraft Corporation of China, COMAC, was envisioned as a direct competitor to Boeing's 737 and Airbus's A320. These models have ruled the skies for decades, capturing the lion's share of the lucrative single-aisle aircraft market. For China, the C919 wasn't just about engineering. It was about challenging the status quo and achieving technological self-reliance. The reception was overwhelmingly positive. Within a few years, COMAC secured over 1,400 orders from more than 40 countries, a staggering accomplishment for a newcomer. But beneath the surface of this success lay a significant problem. Despite the overwhelming demand, COMAC struggled to deliver. With only 11 aircraft produced annually, fulfilling the current backlog of orders would take over a century. So, what's holding the C919 back? The bottleneck of production. The first obstacle lies in the C919 supply chain. While marketed as a domestically developed aircraft, the C919 relies heavily on imported components. Key systems such as engines, avionics, and electronic controls are sourced from Western suppliers. In fact, nearly 40% of the aircraft's parts are imported. This dependency creates vulnerabilities, particularly as geopolitical tensions rise and Western countries impose restrictions on high-tech exports to China. Take the engines, for example. The C919 currently uses the LEAP-1C, a product of a joint venture between General Electric and Safran, a French aerospace company. While this engine is cutting-edge, relying on foreign suppliers means production is subject to external factors beyond COMAC's control. Supply chain disruptions, semiconductor shortages, and fluctuating raw material prices have all compounded the challenges of scaling production. Yet, China is not standing still. Over the years, the country has invested heavily in reducing its reliance on foreign technology. By 2024, over 70% of the C919's components were domestically produced, with plans to achieve full autonomy in the near future. This shift represents a significant milestone, but even with greater self-sufficiency, other challenges remain. A single assembly line. Perhaps the most significant limitation is production capacity. Currently, the C919 is assembled at a single facility in Shanghai. While this plant is state-of-the-art, relying on one location has created bottlenecks in quality control, workforce training, and supply chain logistics. COMAC recognized this issue early on. In 2023, the company announced plans to build a second assembly plant to alleviate pressure and increase output. After months of deliberation, COMAC finalized the site in late 2024. Another facility in Shanghai, covering 330,000 square meters with an investment of $1.67 billion. This new plant will feature 4 automated assembly lines equipped with cutting-edge technology to streamline production. By 2025, COMAC aims to double its annual output to 30 aircraft. Over the next decade, the two facilities are expected to work in tandem, with production capacity reaching 150 aircraft per year by 2031. While this marks a significant improvement, even at 150 aircraft annually, it would take nearly a decade to clear the current backlog of orders. Scaling up production further will require more than just additional factories. It will demand a robust talent pipeline, streamlined logistics, and unwavering quality control. The role of airworthiness certification. Beyond production, another hurdle looms large: airworthiness certification. For the C919 to truly compete on the global stage, it must meet the rigorous safety and performance standards of organizations like the Federal Aviation Administration (FAA) and the European Union Aviation Safety Agency (EASA). Certification from these bodies is considered the gold standard in the aviation industry, granting access to key markets in Europe and North America. Without it, the C919's potential remains limited to regions with less stringent regulations. The process, however, has been slow. Some industry insiders speculate that political factors play a role, as the rise of the C919 is seen as a threat to Boeing and Airbus. Despite these challenges, there is reason for optimism. Overcoming the critics. Despite these strides, critics remain skeptical. Some argue that even with additional production lines, China's reliance on Western technology poses a long-term risk. Others question whether European and American manufacturers might tighten restrictions on supplying parts, further hampering production. Yet, these fears may be overblown. For one, the sheer size of the Chinese market makes it an irresistible opportunity for global suppliers. Cutting off the C919 would mean sacrificing lucrative contracts in one of the world's fastest-growing aviation markets. Moreover, many Western manufacturers have already established factories in China, making it harder for governments to enforce stricter bans. Economic pragmatism often outweighs political considerations, especially in industries as capital-intensive as aviation. China's journey with the C919 is more than just a technological endeavor. It's a testament to resilience and ambition. In a world where the skies are dominated by a few, the rise of the C919 signals that change is on the horizon. Thanks for watching, and until next time.